my next assistant, Aryan. Hello, Aryan. Right. So today we would like to look at the measuring cylinder. And as the name says, it's a cylinder, so we get an idea of the shape and what is used because it's for measuring. A very, very important piece of apparatus in a science lab because we use it to measure volume. So the measuring cylinder is very important as volume is a property used to measure in a lot of experiments. So what makes it be able to measure? So in a measuring cylinder, we have lines or markings, and when we pour whatever we are measuring into it, we just line it up and look at it to where the marking goes. But it's a little bit more complex than just pouring it in. In science, we have special ways in which we use our equipment to make sure we get correct measurements and our experiments work properly. So, a few things. When we are using a measuring cylinder, make sure it's dry. And one very important one is making sure the surface, wherever we are placing the measuring cylinder, make sure it's level, it's flat. When we pour liquids into them, and this is the important part here, read the bottom of the meniscus. When we look at a liquid in any vessel and we look closely, when we look at the top of it where it meets the surface, you'd see there's a little curve. That little curve at the top of the liquid in a container is called a meniscus. So when we fill a liquid up into a measuring cylinder, we would see that slight curve. And we'd use the bottom of that curve to line it up with a mark and read the volume of the liquid. So we are looking at the bottom of the meniscus to get the mark. So another very important feature is how we physically stand and place ourselves when using a measuring cylinder. We're not going to watch it cut from this side. We're not going to watch it so. We're not going to look at it from on top. We're not going to average. So if we see in the diagram, we have low reading, high reading, and a correct reading at the bottom. Even though all we're looking at the bottom of the meniscus, we have to look at it at a proper angle. And the proper angle when we are reading a volume, stoop down with me. We stoop down, don't be afraid to bend the knees, and we look at the measuring cylinder at eye level. So wherever the liquid is reaching, we stoop down and we make sure it's at our eye level to get the reading. So we have our diagram here, and as you can see, we have our markings. Come up here. So we have the person is at eye level, so the person here would be stooping, but they would just show the eye, and the bottom of the meniscus, and look at all the marks we have here. So if you notice, we have numbers in between. So we have 20, and we look at the markings. That means the divisions will tell us what each mark will be. So if this is 20, this will be 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So, very important thing to note that these measuring cylinders come in different sizes, and the units that we would use would be centimeter cube. Sometimes you would see ml, but centimeter cube, would be what we would be looking at here today. So it is important that you understand and look at your measuring cylinder and the graduations and the size before you use it. Depending on your experiment, you may need a bigger one or a smaller one. Right, so we are moving on to our second activity, and here now we would be looking at the soil type and its water retention. We learned already how to use a measuring cylinder, but for the first part of this, we would need to identify all of the things that we would need to do this experiment. Your point. So first we have the filter paper, then we have the beakers, measuring cylinders, funnel, and the soil types, as we saw previously. But just as we had a certain way to look at and use the measuring cylinder, when we use a filter paper, we need to use it in a funnel, and there's a special way to use a filter paper properly into a funnel. So this is our filter paper that we are using. Usually they come in circles of different sizes. But the thing about it, if we are going to use this in this, it's not going to be neat. It could cause errors. So we need to know how to make this into a shape to fit the funnel properly. And how we go by doing this? All right. We fold it in half. Make a line, lift it up. We fold it in half, lift up flat. And now we fold it in half again on the table. Hold it up. So now we see the shape that we got. So it's getting closer to how we would be using it. So when we look at the filter paper folded, we would notice we have 1, 2, 3, 4 sheets here. What we do to make sure our sample doesn't go through the middle, we count 1, 2, 3, put that aside, and separate the last one, and we now have a cone. So our funnel is already a cone. So now the filter paper could fit perfectly in it. They are now the same shape, and we are sure our sample could rest comfortably in there without going through. Another tip when using the filter paper in the funnel is to moisten. Just wet the funnel just a little bit, so when we put the filter paper in, it would stay put. So we're going to look at measuring water. So what we are going to do now, we are going to measure out the water samples, and we would pour them in and look at how they drain. So we would begin with our measured amount of our soil sample, and in this case we have the same amount of clay soil in this funnel, in the first funnel, and the exact amount in the second funnel. So what we are going to do now, we are moving on to the next step, which is measuring the liquid. In this case, we are using the water. So the same things that we talked about when using a measuring cylinder a few slides ago, we are going to do it again. So we are using the funnel, we are going down at eye level and making sure we are looking at the top or the bottom of the meniscus. Bottom of the meniscus. Very good. So we're going to go and gradually, so Aryan, could you help me? So we are going to 30, so we go down to level. We find our marking first, so we see our 30 centimeter cube mark, and we now carefully pour slow. Right, so. Stop. So we need one drop again just to make it to the 30. So just one little drop. One drop, right? All right. So we are looking at the bottom of the meniscus, and it is lining up with the 30 cm cube marking. So that's our reading. We are at eye level. The table surface is flat. So that's a good measurement. Good job, Aryan. Okay. So we are not ready for that yet. So we have to pour out another. So we're going to set this aside. So we have it there. So Ari, could you pour this into the first beaker? So we're going to set this here. And now we are going to do the same thing again for another 30 cm cube. So back again. Right. So we have 30 cm cube, and we'll pour it in this one now. Right. When we are doing our practical experiments, we always keep our work area clear. So the things that we are not using immediately, we always set it aside neatly, because we always want to keep safety in our minds at all times. So we have what we have here now. Let's look at it again before we continue. Measuring cylinder with a funnel, with a filter paper, with our soil sample, sand in this one. Same thing here. The only difference in the second one is that it is clay, same amount as the sand. In the beaker, we have our 30 cm cube of water. And what we're going to do now, we are going to add the water slowly. But the next thing is we have to add it slowly, because we want to make sure when we are pouring the water, it doesn't go up and flows over. We're going to make sure that all the water that we goes through, all the water we pour goes through the sample and goes through the filter paper down into the measuring cylinder. So I'll take note of the time, and Aryan, you could pour gently into that one.